guys, so welcome to another video. And mukhang may mga tatanong no kung Sir may class? Sir may class po ba? Actually wala no kasi naka-purely module ito. So mapapansin nyo kasi 1 unit lang ang i-orientation. Okay? So ang ginawa ko ay tiningnan ko yung attendance sheet tapos tiningnan ko yung mga review. Okay? So feedback daw. Feedback. How is your experience in the online session? Sorry sa boses ko. May tonsillitis ako eh. Sabi dito good. Wow, 65% good daw. Then 34% okay lang me. And then bad, may isang bad. Sino yung isang bad na yan, no? Kung malaman sino yung bad. Okay, so question is how do you think the class can be improved? Okay. So sagot, yes, I think so. I think the best way to improve the class is to make us feel excited every class hours. Okay, so in fairness parang gusto mo every session may video. Hindi naman pwede. Again, hindi designed itong class para maging online, no? Help students maintain focus. Ask for feedback and make class fun. Yeah, this is the feedback really. Ito na yun. I just did. I think the class can be improved by creating a new learning method that gets the students' attention, like an activity which you can enjoy and learn. Okay. Probably sa other subjects na ako yung teacher. Yeah, we can try to do that. Well, having a hangout like free time on DC or YT marathon and students enjoy. Hindi it takes time. Okay. So it's really challenging for everyone to engage in learning through online because the connectivity issues, yeah. Okay, again, basura ang internet ng Philippines. The class can be improved if face-to-face class. Again, right? So wala pa tayong limited face-to-face. And pangarapin na lang natin na magsa-start ng face-to-face by August. So pangarap lang yun. Wala pang kasiguraduhan. I think it will be improved through everyone's participation. Yeah, thank you. Sino man yan? Sagot. Constant communication. Wow. Ano to? Relasyon. Okay. Class. Okay. Comfortable. It needs you needs okay, you need, no? Okay, personal connection with everyone. Yeah, okay. So sorry may tama naman siya. I don't know you don't know me, so so wala talagang connection. Focus. You need to focus. Understand the lesson and enjoy the class. Alright, should the chance at the end. For me, I'm satisfied with the tools being used for the normal lessons and class. Yeah, hi, thank you for appreciating my drawing tab. Yeah, thank you for that. Okay. Furthermore, I think it would be a good experience to gain knowledge tackling the subject. Okay. For me, if the students will listen, yeah, thank you for that. Making fun and compatible. Wow, compatible. What do you mean compatible? By video making of the topics. Okay. Video making the topics. Well, actually, class, I'm recording my lectures now. So, hindi nyo siguro napapansin pa, but I have my YouTube channel. Okay. I have my YouTube channel. I already have 190 subscribers. So, medyo proud na ako dyan. Kasi 190 students yan. Okay, so you see, I have tons of videos already uploaded that contains all the lectures possible. No? So, hindi lang sa EE. So, I have more videos covering dynamics. Okay, so I have experiments as well. I teach engineering data analysis. I have physics, see? I have physics. I have, differential equations. I have mathematics, basically. So, yeah, so I have my videos, really. So, I am the very first on this faculty list to have this kind of luxury, no? I have this kind of technology. So probably yung iba sumusunod na because they found out that si Sir Ikan may mga ginagamit na mga tools, no? Baka gayahin natin si Sir Ikan. So yeah, so yun. Okay. So by the way, having online meetings okay, less online classes. Actually, we're not conducting more online classes, no? Kulang pa nga eh. Focus, serious. Interact with teacher, pay more attention, ask questions if you didn't understand the topic, more discussion to come po, more examples din. Okay, so I cannot give you more examples because this is purely introductory, no? So I think the class can be improved by participating. Can be improved for me. Oh, wow, it's all good. No need to improve. Oh, thank you. Dami. Ang pinaka-controversial dito. Oh, wow, helping each other. Drama. Those magical words encourage us to continue my passion. Overall, it's good. No need to improve. Wow, magical. Okay. Stable internet. So, wala na sa akin yan labas na sa akin yung stable internet. Okay, encourage me to continue my passion. But may mga passion dito. Passion. Okay, it's ending now. Okay, more okay daw ang video kaysa sa modules. Well, yes, definitely, yes. That's correct. Okay, so we're done reading the responses. So I have received 100 responses, by the way. Dami, no? Okay, so let's go and proceed to chapter 4. No? I think this is week 5 lesson. Teka lang, balik lang tayo ng konti, no? Okay? Balik lang tayo konti. So, if you noticed, we have a special quiz on RA 7920. Okay, so just a review. RA 7920 is the law governing EE practice in the Philippines. So, just EE practice in the Philippines. Okay, so I hope that you did well on the quiz. You know, lumalabas din sa board exam actually mga questions na ganyan. Okay, and we have lesson 4. So, proceed na tayo sa lesson 5. This is the last. By the way, this is the last week, no? This is the second to the last week. So, technically, next week, yun yung 5th week nyo. So, you have your midterm and final exam. I think I'll be sending the examination on Monday, 14. Okay. So, that's the combined midterm and final exam. Okay. So, I hope that's clear. Pointers. You don't need pointers. By the way, I provide questions which are purely relevant or similar to the ones that I uploaded in the lectures. No? So, nasa module din. May mga konting mga twist lang. Okay? So, week 5. So, this module discusses how electricity is generated. So, by the way, I think I already discussed in the module, no? So, how electricity is being generated. So, its generation. So, we have transmission, no? Yung mga towers. No, we have transmission. And finally, we have what we call the distribution. No? So, may mga bahay na yan. Yeah. So, distribution. So, one of the key elements, so one of the most important component in the electrical system is what we already know, discussed, which is the transformer, no? The electrical transformer. Hindi yung optimum pride. Hindi yun. Electrical transformer. So, we also have one here. No? Now, electrical transformer is an equipment that is capable of converting electricity or voltage from low to high and high to low. No, it's vice versa. So practically speaking, electrical transformer makes the whole electricity generation, transmission, and distribution possible. No? Why is that, Sir Ikan? So the reason for that is because if you can remember, if you can remember the previous coverage of modules, our power plants, our power plants are located thousands of kilometers away from us. So, mga homes, it's thousands of kilometers. So imagine the amount of losses we have. When we say losses, really, it's purely resistance. Resistance, as defined, is the property or the phenomenon which resists the flow of electricity. Now, the longer ARPLA. Yeah, ARPLA. Now, the formula for resistance is the resistivity of the material. This is constant, by the way. Now, this wire has a resistivity or rho. No? So, constant yan for every material. So, we have a different rho for copper. We have different rho for aluminum. Basically, every kind of material has their own rho. Now, the resistance is directly proportional to its length. So, as again said, directly proportional. So, it means to say that the higher or the longer the larger or the longer the length of the wire, the greater the resistance. As I already said, thousands of kilometers yung distance or yung separation ng power plants to our homes. Now, in order for us to overcome resistance, we have to increase the voltage, really. Now, maintindihan nyo yan in the later years, sa electrical circuits. Now, how higher voltages overcomes resistance. But the point really is that electrical transformers makes this electricity generation from power plants to our homes possible. Because again, the distance, So, when you say na LDR pala kayo, yeah. So, ano yung transformer niyo? I don't know. We find that one out. Anyways, so let's proceed. So, that's it. That's a concept, really. Now, going back to the lecture. So, that's the recap, So, now we are in the distribution, the whole distribution process. So, we are going to emphasize here. We're going to focus here, really. Okay, focus. So, distribution. Okay, next slide. Yeah. So, in distribution, so there are terminologies that you have to understand. We have the wattmeter. Okay, so we have the distribution line. So, kanina may transmission line. We have distribution line here. We have brownout, blackout, commercial consumer, residential consumer, industrial consumer. Okay, now when we say distribution, now we're talking about a distribution. It mainly speaks of three things. We have the industrial consumers. Sometimes they say it load, no, loads. We also have commercial consumers, or when they say loads, no, loads. And we also have residential. Okay, I'm going to spill the bean. Every every consumer or every kind of load has their own different rates. When I say rate, so they have their own different rates, no, per kilowatt hour. They have their own different kilowatt rates. When I mean to say is, there are times that commercial establishments pays more than residentials, or residential consumers pays more than industrial consumers. So iba yung rate, no. So ibang rate dito, let's say, I don't know, maybe here it's 9 pesos. 9 as I remember, no, I think it's 9 pesos per kilowatt hour. Okay? And here I think it's around 6 or 7, I don't know. Industrial consumers is a bit lower. So let's say 8 pesos, no, per kilowatt hour. We also have here, let's say 8.5 per kilowatt hour. So that's just an example. So it's not an exact number, really. So what I'm saying is they have their own different rates. Okay? They have their own different rates. And the reason for that, sorry, guys. The reason for that is because each kind of consumer or loads has their own different energy profiles. Okay? So medyo malalim lang ng konti, no? So when we say energy profile, okay? Energy profile is like this. This is the time in the day, you know. So let's say we have 8 a.m. We have 10 a.m. We have um, we have sorry 12 p.m. We have 5 p.m. and we have 8 p.m. Also here, gawa din tayo ng graph. So we have 8 a.m. We have 12 p.m. 5 p.m. 8 p.m. Okay, kulang yata. Dagdagan natin ng 10 p.m. We have 12 p.m. And for residential, it's around the clock. So we have 8 a.m. No, it's not 8 a.m. really. It's 5 a.m. So we have 9 a.m. We have 12 p.m. We have 3 p.m. We have 6 p.m. Kulang ulit. We have 9 p.m. We have 12 p.m. Okay. So when I say load profile or energy profile, it's like this. Zoom in tayo. So when we say industrial consumers, so ito yung mga gumagawa ng sabon, gumagawa ng mga gamit-gamit, mga bagay-bagay. So ito yung mga factory, no? So when we say factory, they are typically open, no? 8 a.m. to 6 p.m. I think. 8 a.m. to 6 p.m. Okay. How about for commercial? No. When we say commercial establishments, ito yung mga mall. No? So when we say example, SM. So SM, usually bukas sila ng, I think it's 9, no? 9 a.m. 9 a.m. to 10:50, minsan nga 11 no? 11 p.m. Sa residential naman, wala tayong ganun. Kasi, ang bahay natin bukas naman yan eh. Bukas yan buong araw. O buong gabi. Buong araw gabi. So, walang time. Now, this is the reason why iba yung rate, no? Iba yung rate. It's because the industrial consumers, predictable. Predictable yung kanilang load. So, usually, industrial consumers take a bulk of energy. So, when I say bulk, no? So, for example, ito yung commercialista, ito yung industrial, no? For example, ito yung power plant, ito yung factory. So, ang gagawin niya is, kukontak siya directly dun sa, no, sa supply. Tapos, ang sasabihin niya, I need this energy. No, usually they say it's, I don't know, I think it's 500 megawatt hour. No, they say 500 megawatt hour or so. Or let's say 1,500 megawatts na lang. So, it's a bulk, no? It's bulk. Also, sometimes they say, this is our load, no? So, fixed sila. So, what I'm saying is fixed. So, basically, ganun din sa commercial. So, they also say the same thing. So, we are asking for this kind of energy. So, it's bulk. So, they are purchasing in bulk. No? So, minsan nga, nakakonect na sila mismo sa mismong power plant. So, there are times na yung factory, for example, this factory, located in Laguna, nakatap siya directly sa isang pinakamalapit na power plant. So, ganun. So, the reason why they have different prices for kilowatt hours because, again, if you're going to graph this one, so, ito yung magiging, for example, yan yung 1,500 nila. No? So, consistent yan. Hindi pala watt yan eh. Hindi pala hour. Megawatts yan. Megawatt. Hindi pala energy yan. Power. Okay? Now, why did I change? Bakit mas appropriate ang energy? When I say energy kasi, okay, ang unit kasi ng energy is kilowatt hour. So, when we say kasi energy, there is already a time. No? However, on the other hand, when we say power, it's purely watts in lang. Okay? So, if you again, going back here. So, during 8 a.m., no? So, mababa pa yan. Usually, mababa. Yeah. So, yan. Yan ang 1,500, no? Watts. So, continuous yan. Continuous yan hanggang 6 p.m. Tapos bababa ulit. Mababa yan kasi syempre yung mga ilaw na lang. Yan. So, kind of predictable, no? This is kind of predictable because, again, we are assuming that the energy requirement or the power requirement is fixed. No? Fixed in this particular time frame. Oh, if we're going to compare this one with the commercial load establishments, so they're not starting 8 a.m. No? Usually, mga mababa pa yan. They will ramp up by 10 or 9. No? 9 a.m. Okay, tapos fix ulit yan. Kasi bukas lahat ng ilaw. Hanggang 11. Bukas ng sine, ganun. Tapos escalator, tapos biglang bababa yan. Kasi magsisimula na mag-shutdown yung mga establishments. No? So, babalik siya sa original niya. Okay, so, it's basically the same thing, no? Titingnan nyo. The energy or the the peak power starts from 9 a.m. and then subdues this particular time frame. No? Ito yung operating hours. So, kind of predictable. No? Kind of predictable. Kasi they already know that this is the peak. This is the amount of power that I need for this particular time. No? Particular time. Now, if we're going to look at residential, no? Can we say that it is predictable? The answer is no. No? Hindi siya predictable. When I say hindi siya predictable is because sometimes nakadepende sa mood, nakadepende sa requirement. Minsan, may dumatating na bisita, may nawawalang bisita, minsan wala ka sa bahay, minsan wala ka sa bahay, kaya bumababa. Kung minsan, for example lang, 5 a.m., magtitipla ka na ng kape, so mag-iinit ka ng, So, meron yung power kasi, syempre tulog ka, no? May ilaw ka, aircon, electric fan, tapos 5 a.m. tataas yan kasi magkakape ka, magluluto ka, tapos biglang bababa yan. Kasi ang gumagana lang, kung wala ka, for example, wala ka sa bahay, no? Tatrabaho ka. So, nasa office ka, so mababa yan. No? So, mababa yan. Yan, baba. Tapos sa office ka lang. Yan. Tapos mga alas 6, dumating ka na ng bahay. No? Tapos bigla ka nanood ng TV, bigla may naginuma, may nag-karaoke, may nag-weldy, yan, tapos tulog, yan, aircon. So, the problem with this kind of setup is it's really unpredictable because there are times na you decided not to drink coffee. So okay, ibang drawing tayo, ibang line. No? Gamit tayo ng purple or green. So, there are times no na For example, bumili ka ng bagong, for example, nag-decide ka na wag na mag-electric fan kasi malamig, so bababa yan. Tapos decide ka na decide ka na wag na magkape kasi may ininit pala sa stove, so bababa. Okay? Tapos may biglang dumating na bisita sa taas. Tapos may pinapagawa kang railing, so kailangan mag-welding, tataas ulit. No? May pinapatrabaho kang construction. Tapos bababa yan. Okay. Okay. Tapos dumating ka. Tapos nag-party. Tapos biglang nag-burn out. Tapos kuryente ulit. Alright, man. So what you notice is that it's really difficult to predict the energy pattern or the energy loading of residential. So that is the reason why may iba-ibang rates, no? Now, Sir Ikal, ano naman ang connect niyan, no? Ano naman ang connect? Bakit natin pinag-uusapan yung different energy loading? Now, punta tayo dun sa lecture. This one. Okay? Balik tayo dito. Electrical system stability, supply and demand. Alright? So, naintindihan niyo na kung bakit ko pinag-uusapan yan. So, kanina, pinag-uusapan natin ay demand. No, demand. So, demand. Ito yung demand. So, predictable yung demand ng industrial. Predictable din ang demand ng commercial. Yung residential medyo hindi masyadong predictable. No? So, Sir Ikal, bakit napaka-importante maging balanse ang kuryente? Okay, ito yung sagot. Okay? So, kailangan maging balanse ang supply at demand or kuryente natin. Kasi, ganito yon. Kasi, okay? Kasi, walang battery. Walang battery. Okay? So, walang battery sa systems natin. So, ibig ko sabihin is, yung power plant, walang battery para i-store yung energy niya papunta sa bahay or sa commercial establishment, sa industrial. So, wala. So, basically saying, yung supply na yan, okay, nagbabago din yan. Okay? Sumusunod ang supply sa demand. Okay? So, for example, ito. For example, no? Wait lang mamaya. Ito na, explain ko na lang. Kailangan sumunod yung supply sa demand. Bakit? Kasi ganito yun. Why is this? Because electricity is generated in real time. No? So, pag umanda rin generator, mapapansin nyo, no? Umanda rin generator, tapos kapag tinanggal nyo yung load niya, biglang bibilis yung ikot. Tapos kapag nilagyan na naman ng load, biglang babagal naman yung tunog. So, parang ganun eh. So, what is at stake here? Now, what's at stake here is what we call the frequency. The system frequency. No, hindi lang yung system frequency, also the voltage. No? So, in the coming years, maintindihan nyo rin yung point na yan. So, what's really important is we have a stable frequency. Here in the Philippines, we use 60 Hertz. No? In voltage as well, we have 230 volts. No? So, we have to maintain these voltages. Now, kapag unpredictable yung demand, yung supply, hindi agad-agad yan makakasunod. So, ang tendency, kapag masyadong mataas yung demand, kailangan magtaas din ng supply para maging balance sila. So, ang tendency, kapag sobrang taas yung demand, hindi makasunod yung supply, magba-brown out. So, doon tayo magkakaroon ng tinatawag na load shedding. Okay? So load shedding. Okay, balik tayo sa module. So, unlike what we use in our homes, we store electricity in batteries, but electricity in the grid is not like that. So, there must be a constant lookout. No? There must be a constant lookout. So, kailangan talaga balance yung energy supply and demand to keep things stable. Okay? So, when the demand is bigger than the supply, as I said before, this means more consumer uses power. No? And power plants must adjust, no? Must adjust. So, kailangan humabol. So, when the demand is 50 and the supply is 30, kailangan dumagdag ng 20 to balance the things. So, this scenario will force distribution utility to reduce the demand of consumers by cutting some of them. So, that's what we call load shedding. So, may mga kaya tayo tinatawag mga brand out. Mga biglang brand out, no? So, when distribution utilities implement load shedding, they prioritize based on the importance and type of consumers. So, they prioritize na based on the type of consumers. So, for example, in Manila, in Metro Manila, this is complicated by the way, ang pinakauna nilang sineshed ay residential. Una nilang doon madalas nagkaka-burn out sa residential. So, may tendency is may burn out na barangay, may burn out na city, pero may kuryente pa rin yung mga mall, may kuryente pa rin yung mga mall, may kuryente pa rin sa mga factory. Napapansin nyo? Okay? Because they prioritize. No? So, we have basically three things that you have to understand. So, we have brownout, we have power interruption, and we have blackout. No? So, we have brownout. So, when they say brownout, there is a huge demand for electricity. Okay? And there's a huge demand of electricity, but mean supply mababa. So there will be brownout for that one. So power interruption is kapag may ito may be scheduled for service improvement and scheduled due to emergency. So power interruption, no? So I think the most appropriate term dito sa atin sa Romblon is power interruption, hindi brownout, no? So biglang brownout. So the most appropriate for me is power interruption, no? Because the power interruption can means that may breaker na pumutok dun sa poste sa kabila, or so may pumutok na fuse, kailangan magbawas ng load shedding, load shedding. So I think the most appropriate again is power interruption, no? So biglang pag example sa bahay niyo biglang nawala yung kuryente, sabihin niyo may power interruption, ganun. So blackout on the other hand, blackout, no? Blackout is meaning is talagang buong tablas walang kuryente. So that's blackout, no? So total or partial collapse in the system power grid, loss of electric power. So wala talaga siya. So in the grid, no? In the grid. Okay? So typically, the residential consumers are the first one to be sorted for load shedding, which is true. Residential talaga. So this happens to homes properly call it brownout, no? It's proper to call it brownout, but when consumers were cut off from supply, we call it brownout, no? So when we say the higher demand, tapos biglang nawala yung kuryente, we can say it's brownout. But if there's power interruption, the distinction between power interruption and brownout is that the power interruption is only for a specific area. For example, biglang pumutok yung fuse do or may biglang sumabog na transformer dun sa particular na barangay, so yung buong linya ng may barangay na yun walang kuryente. So that's power interruption. So hindi mo agad pwede i-rule out na brownout, no? So hindi agad. So probably there's only a specific problem. So what if the opposite happens? So what if there is more supply than there's demand? Okay. So kanina is we have more demand than supply. So what if we have more supply than demand? Okay. So this is also not good because when we say the supply is high than the demand. So kailangan magpatay ng mga power plants, no? This means prioritized shutdown of power plants will be implemented just like in load shedding, no? Typically, power plants are not all the same, which is true. Now, we have, as we mentioned in the previous module, we have solar, we have wind, we have coal, we have hydro, we have natural gas. So we have a variety of things, so supplies. No? So the first supply na isa-shut down is typically yung mga mabibilis. So we have the diesel, we have the wind, we have the solar. So basically sila yung mga sinashut. Sila talaga yung mga hindi pinapansin masyado kapag masyadong mataas yung supply. So hinahayaan lang sila. So they can do it on our own. Now the question is, Sir Ikal, bakit hindi pinapansin yung mga coal, no? Bakit wala siya sa supply shedding yung load, no? O sa supply shedding yung mga coal-fired power plants and hydro, okay? Bakit hindi sila kasama, Sir Ikal? Okay. Yung reason, no? The reason kung bakit hindi kasama sa plant shutdown yung coal or geothermal, we have natural gas. Minsan, natural gas kasama siya actually. Nat gas din pala minsan. Nat gas. Hydro. Okay. The reason why kung bakit hindi sila kasama sa mga plant shutdown dahil sila ang tinatawag namin na base loads. Okay? So sila yung nagpo-provide ng consistent na supply. No? It's either consistent, no? It's either consistent sila or sila ang may pinaka mabagal or slowest startup. When I say slowest startup, sila yung mga tipo ng mga planta na kapag pinatay mo, ay matagal silang bumalik, no, sa operation. So, Sir Ikal, bakit po ba ganun? Okay, as I mentioned, okay, kailangan ma-maintain yung balance between the supply. Now, yung demand kasi ay bigla-bigla biglang nagbabago. Minsan, biglang tataas, biglang bababa, tapos biglang taas, biglang baba. So, kapag sila kasi shut down, it takes hours, no? It takes hours for them to go back online. It takes hours for them to go back online. Unlike yung dito sa Sueco, yung diesel, kapag gusto nilang ipa-on, paandarin lang nila yung generator, nandiyan na. Pero itong mga to kasi matagal, hindi sila ganun kabilis. Bakit? Okay. The reason for that is going back to I think the first module, no, yung how power is generated. No? Because if you can remember, when we say coal-fired power plants, sila yung tipong nag-ooperate sa steam. So naalala nyo naman, di ba, kung gaano katagal painitin ng tubig. So kung kayo nga gusto niyo magtimpla ng kape, papakulo muna kayo, it takes time. So how much more kadami-daming kalaki-laking tubig. So it takes time para uminit sila, di ba? So So yun ang reason kung bakit sila yung mga hindi talaga pinapatay. Sila yung mga base loads. Kasi sila yung mga slow startup. At sila din yung consistent, no? Yeah. So yun ang reason. So I hope na clear na. Okay? Alright. So naintindihan nyo na, meron tayong load shedding, meron din pala tayong supply shedding, yung mga reduction, no? Yeah, meron tayong ganun. So, in the coming years, no, kapag tumagal kayo dito sa EA, probably 4th year nyo, dun nyo rin may make sense yung mga pinagsasabi ko dito sa EA orientation. So, kaya sabi nyo, para hindi na kayo magulat, no? Ganun pala yun sa EA, ganun pala yun kapag pagdating sa 4th year, no? So, sinasabi ko na ngayon. Okay, so, part and distribution line, so, yeah, you can use this one for your reference. We have transformer, we have pole, we have the service entrance, so we have the connection, we have the meter, you know. Okay, electric bill. Okay, so na-discuss na rin dito kung paano ko compute yung electricity, no? So I think hindi ko na kailangan discuss. Okay, so I think this is really okay now. Alright, so I think that's it. We're good. So have your initiative. Please have the initiative to read the modules yourself, and also if you have your questions, you can visit YouTube and ask the questions there. I think it's more appropriate kasi mas marami silang mga pictures and demonstrations or videos for that one. So I think this is okay for now. So bye-bye.